Hi, my name is Judy Rackison. I'm the Deputy Project Scientist on the Fermi Gamma Ray Space Telescope. I'm here today to watch a video with you of 14 years of observations collected by the Fermi Large Area Telescope, or the LAT. This is the primary instrument on the Fermi mission, and it surveys the entire sky every few hours. This allows it to do a lot of really cool things. It can look at sources that vary on timescales from a fraction of a second to years on end. There are two different kinds of maps that we're going to look at. One map is in galactic coordinates. That means that there's a thin band across the middle of the image, and that's the Milky Way. You've probably seen images of the Milky Way in the optical. The Milky Way in the gamma rays looks kind of similar, except we're looking at a number of different types of objects. We'll also look at the gamma ray sky from another perspective where we're looking up and down out of the galaxy, which gives us a much better view of the extragalactic sky and all the sources way outside our galaxy in the distant universe. In this map of the gamma ray sky, where we have blue and red and yellow tones, what we're seeing are actually intensity maps. Fermi isn't an imaging instrument like you think of Hubble or Webb. What it is it's actually a photon collecting instrument. It's a particle detector in space. And we make these maps by adding up all of the photons we collect. In this case, these are over 4 days. The color scheme, blue, red, yellow, this is just a way for us to visualize it, because our eyes don't see gamma rays. Those circular sources that you see in the galactic plane are actually individual objects. Most of those are pulsars. These are rapidly spinning, dense stellar remnants called neutron stars that are actually varying, pulsing on timescales from hundreds of times per second to several seconds. We see sources above and below the galactic plane. Those are largely blazars. What that is a supermassive black hole, millions to billions of times the mass of our sun, the center of a galaxy, that is active. That means that there's gas and stars falling into it, and it produces jets of emission, and they're very chaotic systems. So they're turning on and they're turning off, and that's actually the source of a lot of the variability that we'll see throughout this movie. We have a team of dedicated scientists, what we call the flare advocates. Their job is to look at data every day that comes from Fermi and look for these flaring sources. It's not just so that we know that they're there and that we catalog them, but some sources are interesting enough that we want to tell our friends, other space and ground-based telescopes, that they should go look at the same place and collect multi-wavelength data so that we can better understand these outbursts. You might notice that there are a few odd discontinuities in these images. This is a result of holes in the data that we didn't want to be distracting, so we patched those images using frames before or after. If you look carefully, you see one source that isn't like the others. It's actually moving, and sometimes it gets brighter or fainter. That's actually just the sun. The sun is an interesting source in the gamma rays. It's not the brightest source in the sky like it is in the optical, but it's prominent in its quiescent state, where we're just seeing cosmic rays interacting with the solar atmosphere. We also see it when there are solar flares. That bright flash right there was a spectacular solar flare. You may have noticed a lot of variations in the sky over time. It's not the galaxy itself is getting brighter or fainter. It's that as Fermi surveys the sky, it doesn't do it completely evenly. Over many years, we accumulate a very nice, even exposure of the sky. But when we look at short timescales, what we're seeing are variations in the survey, not actual variations in the sky. But when you do see individual sources, those are real variations from our own solar system out to the distant universe. The sky exposure pattern seems to change a bit starting about 2018. This was due to a hardware issue where one of our solar panels stopped rotating. It's still fully functional, and Fermi has enough power to operate both instruments and the observatory. What it means, though, is that the way we observe the sky and the timescales in which we survey have changed a bit. In our 14-year map, there's over 7,000 total sources. Almost 4,000 of those are these active galaxies, these blazars. There's several hundred pulsars, and in total, something like 2,000 of these sources are variable. This video showing the first 14 years of Fermi observations is just the beginning. Fermi continues to observe the dynamic sky every day, and we hope it'll continue to do so for many years into the future.